Alright, in this video, we are going to see how to find a portion of the lateral area of a cone. So what do we mean by that? Here is the whole cone. Let's say we just want the lateral area of the bottom portion right here. And if you make a cut, you can open it, so it looks like this picture. I just want this right here. And I'm going to just call this to be a band. We want the area of this band. And of course, you can see all the labeling. We have to consider the radius of the base circle. We'll call that to be R2. And then we also have to consider the circle up here. I will just call that to be R1. And this distance, we'll call that to be L. And this right here, we'll call that to be L1. Well, if you want to find this area, of course, you want the whole thing minus this one that you don't want, right? And let's recall how to find the lateral area of the whole cone. When you have a cone like this, you can make a cut right here. You can open it, so you actually get a sector like that. Well, to get this area, you need to know the radius of the base circle, which is R, and then the standard height. And in fact, all you have to do is pi times R times L. Even though you see the picture right here, this right here is 2 pi R. It's because on the base right here, you have to go around the circle one time. And that's the circumference on the bottom right here. So you have the 2 pi R here. But you have to remember the area of this right here is pi times R times L. Anyway, here we go. To find the area of the band, I want the whole thing. And I want to consider the radius of the big base right here, which is R2. So that will be the R right here first. I'll put on pi times R2. I just need the radius for the bottom right here. And I also need to find the whole length, right? Because I want to get the big one first. So this is L1, this is L. The whole thing is going to be L1 plus L. And let me just write this down right here. L1 plus L, like that. And of course, we have to put that in the parentheses, like this. And that's the the whole area. And now we just want to subtract this right here. And everything is in blue, so I'll just write it down in blue. I will have to minus, pi is still pi, and the radius right here, which is the R1, just care about the radius, and the standard height, which is L1. So that's pretty much it. And now let's do some algebra from here. First of all, of course, we can distribute this, and we see that this is going to be pi R2 L1, and then we add it with pi R2 and L. And be careful with the subscripts and all that. Anyway, right here we still have the minus pi R1 L1. And now I see that we have L1 here and L1 here. So perhaps I will actually put these two terms together, and then I will also factor out the L1 and also the pi. So here we go. Right here, let me factor out. In fact, I will factor out the pi from everybody. All right, I'll factor out the pi from everybody. This and that now, I will have the L1. I will also factor that out. And then it will be R2 minus R1, like that. Once again, the pi is outside. And then for this term, the pi will be out, so we'll just have plus R2 L, like this. So far so good, but can we do better? Because we have this right here. This is R2 minus R1. Well, if you look back here, in fact, you can draw a line straight down and you can see some similar triangles, right? So let's do it real quick right here. Look at the top portion here. You can have the blue triangle, which is like this. That's L1, and then that's R1. And you can look at the whole thing. The whole thing here is, the side is L1 plus L, and then the bottom here is R2. So based on similar triangle, I'll just put a note right here. Let me just do L1 over R1 right here. And that has to be equal to this over that. So we will have the L1 plus L over R2. And now what can we do next? Let's just cross multiply, do some typical algebra. So you see, if I do that, I will have L1, let me do everything red. L1 times R2, right, this times that. And that's equal to R1 times this, so R1, L1, R1 times that, plus R1L, right? And what we'll do next is, I will move this to the other side, and both of terms have L1, so I can factor that out. So let me do that, L1, and we will have R2, and then minus R1. And this is going to be nothing but just R1 times L. So, like that. Check this out. L1 times R2 minus R1 is precisely this term here. And now we can replace this with that. So, to continue, you get this is equal to pi times, this is just R1 times L. And then, of course, you still have to add it with R2 times L. Of course, both terms have the L, so we can factor that out. And let me just write it down for you guys right here. Pi times R1 plus R2. And then both terms have the L. I will just factor it and then put it outside right here. So this is good. This is wonderful. All right, but I don't want to end it here because R1 plus R2, we can do better than that. So let me just make another note right here real quick. This is what we are going to do. We are going to define R to be the average of R1 and R2. So we can just say R1 plus R2 over 2. So if you want to look back to the picture here, R will be in the middle right here. It's the average, right? So it's R right there. And of course, you can see this portion here, it's going to be the 2 pi R. You take this for the radius, rotate, and you get the circumference. But you know, it's this length right here. Anyway, this is the average of R1 and R2, and I will just multiply both sides by 2. So you get 2R equals R1 plus R2. And look at this. I will replace 2R with that. And this is going to be useful when we are doing calculus. So I will put down 2 in the front, and then we have the pi, and then we have the R, and then we have the L. So this right here is how we are going to find the area of this band right here. Anyway, this is it.